You are standing in Cusco, Peru, in front of a wall that should not exist. Not because it is fragile or rare, but because building it requires a level of precision that makes modern stonemasons shake their heads. This is not a wall made of bricks or roughly hewn blocks. This is a three-dimensional jigsaw puzzle carved from stones weighing up to 120 tons, fitted together so tightly that you cannot slide a sheet of paper between them. No mortar, no gaps, just rock on rock, creating seams so perfect they look like the stone grew that way. The conventional story goes like this. The Inca built these walls in the 15th century using bronze tools, stone hammers, and enormous patience. They somehow quarried massive blocks of andesite and diorite, two of the hardest stones you can work with, transported them across mountainous terrain, then shaped each one to fit its neighbors with millimeter precision. The official narrative frames this as a triumph of persistence and manpower. Thousands of workers, decades of labor, trial and error, until the pieces fit. It's a nice story, it's logical, it respects what we think we know about technological progression and human capability. But here is what makes engineers deeply uncomfortable. These walls are not just fitted together well, they display a level of geometric sophistication that should not be possible with the tools the Inca are said to have possessed. We are not talking about flat surfaces meeting flat surfaces. These are complex, three-dimensional interfaces where each stone has anywhere from 6 to 12 contact points with its neighbors. Each surface curves and angles in multiple directions simultaneously. The blocks are not uniform shapes that could be mass-produced or templated. Each one is utterly unique, and yet each one meshes perfectly with every stone it touches. Think about what that actually requires. To achieve this level of fit, you need to know the exact three-dimensional geometry of every surface that will contact another stone before you finish shaping it. You are essentially creating a complex polyhedron that must mate perfectly with multiple other polyhedrons, none of which follow standard geometric forms. Modern CAD software can model this. Modern CNC machines can cut it, but doing this by hand, with stone hammers and bronze chisels, with each block weighing multiple tons so you cannot easily test, fit, and adjust, would be absurd. The mathematics alone should be staggering, let alone the physical execution, and yet these walls exist. You can walk up to them right now, run your fingers along seams that have survived 5 centuries of earthquakes that leveled Spanish colonial buildings built on top of them. The Spanish conquistadors saw these walls and assumed the Inca had used magic or made a pact with demons because they could not conceive of any natural human process that could produce such work. We have become more sophisticated in our explanations, but we have not actually solved the fundamental puzzle of how this was done. The precision becomes even more remarkable when you examine the interior surfaces of these joints, not just what is visible on the wall face. French engineer Jean-Pierre Pratzen conducted detailed studies of Inca stonework in the 1980s and discovered something that deepens the mystery. The contact surfaces between stones are not just tight on the exterior face where you can see them. They maintain that same precision deep into the wall structure, sometimes for 18 inches or more into the joint. This means the Inca were not just creating a pretty facade, they were achieving true three-dimensional mating of complex forms throughout the entire depth of contact. Pratzen attempted to replicate Inca stonework using the tools they supposedly had available. He managed to shape andesite using river cobbles as hammers, proving it could be done. But the process was extraordinarily slow, and achieving anything close to the precision visible in Inca walls proved effectively impossible. The best he could manage was what he called acceptable fit, meaning gaps you could see but could not stick your fingers into. The actual Inca walls show gaps you cannot see at all, gaps so fine that razor blades will not fit into them. The difference between acceptable and unmeasurable is the difference between good craftsmanship and something that challenges our understanding of what pre-industrial humans could achieve. Here is what makes the timeline even stranger. The most sophisticated stonework in Cusco is not found in the latest Inca constructions. It is found in the earliest layers, particularly in structures like Sacsayhuaman and the foundations beneath Cusco's colonial buildings. The Spanish, when they conquered Cusco in 1533, found walls so perfect they kept them as foundations for their own buildings. These were not recent constructions. The Inca themselves told the Spanish that these walls were already ancient when their ancestors arrived in the valley, built by earlier peoples whose names had been forgotten. The Inca claimed to have learned from these structures, but never claimed to have built the most impressive examples. This inverts everything we expect from technological progress. Skills should improve over time. Craftsmen should get better with practice. Civilizations should advance from crude to refined. But the archaeological and architectural evidence in Cusco suggests the opposite. The oldest work is the most sophisticated, and quality declined over time. Later Inca construction, clearly attributable to the 15th and 16th centuries, shows joints that are good but not impossible. The stones fit well, but you can see the seams. The blocks are smaller. The complexity is reduced. It is as if later builders were working from a template they understood but could not fully replicate, like medieval Europeans copying Roman engineering without quite grasping the underlying principles. The stone cutting technique itself presents problems that conventional explanations struggle to address adequately. To create these multifaceted, precisely mating forms, you need to accomplish several things simultaneously. You need to measure and map the three-dimensional geometry of adjacent stones with extreme accuracy. You need to translate those measurements into a cutting pattern for your new stone. You need to execute that pattern in one of the hardest materials available, maintaining precision throughout the shaping process, even as you are hammering away tons of excess material. And you need to do all of this knowing you cannot really test fit the stone until it is nearly complete. Because once these multi-ton blocks are set in place, moving them for adjustments is not a casual operation. Modern stonemasons, when asked to replicate this work, consistently say the same thing. It would be possible with modern tools, but it would be extraordinarily expensive and time-consuming, even with laser measurers, diamond-tip saws, and precision grinding equipment. With only bronze and stone tools, the consensus ranges from theoretically possible but impractical to effectively impossible, given the number of stones involved and the perfection achieved. And yet the Inca, or whoever actually built these foundations, produced not just one wall but extensive networks of precisely fitted stonework throughout Cusco and surrounding sites. The earthquake resistance of these walls adds another layer to the mystery. Cusco sits in an active seismic zone. Major earthquakes have struck repeatedly over the centuries, including devastating quakes in 1650 and 1950 that reduced the Spanish colonial buildings to rubble. The Inca walls, particularly the famous 12-angled stone and the surrounding structures, survived essentially intact. The stones shifted slightly but did not collapse. They actually moved as a flexible system, absorbing and distributing seismic energy in ways that modern engineers recognize as sophisticated but struggle to fully explain. The conventional explanation for this earthquake resistance focuses on the precision of the fitting and the slight inward lean of the walls. Both factors certainly contribute, but recent analysis suggests something more subtle is happening. The shapes of the stones themselves, with their multiple contact points and complex interlocking geometries, create a structure that behaves almost like a three-dimensional lattice rather than a simple stacked wall. Forces applied to one stone distribute through multiple pathways to neighboring stones, dissipating energy rather than concentrating it. This is not just good building practice. This is structural engineering at a level that requires sophisticated understanding of force distribution and material properties. Think about the knowledge system required to develop this technique. Someone had to understand not just how to shape stone, but how forces move through rigid structures, how to design joint geometries that would lock together mechanically while still allowing slight movement during seismic events, and how to implement these principles consistently across large-scale construction projects. This implies not just talented craftsmen, but engineers, people who understood structural principles at a theoretical level and could translate them into practical building methods. The tool question becomes even more problematic when you examine specific features of the stonework. Many blocks show evidence of having been shaped from both sides simultaneously or nearly so, suggesting work was done while the stone was accessible from multiple angles. Some stones display curved surfaces that would require either extensive grinding with abrasive materials or some method of shaping that goes beyond simple percussion. The volume of material removed from some blocks, carved away to create their final complex forms from much larger parent stones, represents hundreds of hours of labor per block, even with modern tools. Multiply that by thousands of stones across Cusco's ancient walls, and the total labor investment becomes difficult to reconcile with the timeline available and the other demands on Inca society. And then there is the quarrying problem. The stones in these walls are primarily andesite and diorite, volcanic rocks with the most hardness of 6 to 7. This means they are significantly harder than bronze, which has a hardness of 3 to 4. You can shape softer stone with harder tools, but shaping harder stone with softer tools requires abrasion rather than direct cutting. Pratzen demonstrated you could use river cobbles, which are harder than bronze, as hammers for percussion shaping, but this produces a pecked surface that then requires extensive grinding to achieve smooth, precise faces. The time required expands dramatically, and the precision becomes harder to maintain. Some researchers have proposed the Inca used a lost technique involving plant-based acids or other chemical processes to soften the stone for easier working. No archaeological evidence supports this hypothesis, but it keeps resurfacing because the alternative, that everything was done through percussion and abrasion, seems almost impossible given the results achieved. Other theories suggest knowledge of thermal shaping or other methods that would not leave obvious archaeological traces. These ideas remain speculative, but they emerge from a simple observation. What exists in Cusco is difficult to explain with the tools and techniques we are confident the Inca possessed. The transportation question compounds the mystery. Many of the largest blocks at sites like Sacsayhuaman weigh over 100 tons. Some estimates for the largest stones reach 200 tons. Moving these masses across mountainous terrain to construction sites requires not just labor but sophisticated engineering systems for load distribution and force application. The Inca did not have wheeled vehicles, draft animals large enough to pull such loads, or metal tools strong enough for complex mechanical systems like pulleys and cranes as we understand them. They had ropes, wooden levers, log rollers, and enormous supplies of human labor. Teams of modern engineers have attempted to move multi-ton stones using Inca-era technology. The results demonstrate it is possible, but extraordinarily difficult. Moving a 20-ton block requires hundreds of workers and moves slowly enough that covering significant distances becomes a project of months or years. Scaling this up to 100 or 200-ton blocks means force requirements increase geometrically, not arithmetically. You need stronger ropes, thicker log rollers, more leverage, and more precise coordination of massive labor teams. It is theoretically possible, but doing it repeatedly for thousands of stones while simultaneously quarrying, shaping, and precisely fitting them into complex structures represents an organizational and engineering challenge that pushes the boundaries of what we think pre-industrial societies could accomplish. Recent archaeological work has identified some of the quarries used for Cusco's stonework, located several kilometers from the city at sites like Rumicolca. These quarries show evidence of stone extraction with partially cut blocks still visible in the parent rock, but they do not show clear evidence of how the precision shaping was accomplished. You do not find areas with accumulated debris from shaping hundreds of tons of stone per block, the kind of waste material you would expect from heavy percussion work. You do not find clear evidence of large-scale grinding operations that would leave distinctive wear patterns and deposits of stone dust. The quarries show where the stones came from, but not how they were transformed from raw blocks to precision architectural elements. The absence of a clear learning curve in Inca stonework bothers many researchers. When humans develop complex technical skills, they practice. Early attempts are crude, and refinement comes with experience. You should see experimental work, prototypes, and failed attempts, but the earliest examples of precision Inca stonework appear fully developed. there are not obvious examples of learning to fit stones really precisely that show intermediate levels of skill. The technique seems to appear already mature, already capable of producing work that modern craftsmen struggle to replicate. This pattern appears in other aspects of Andean culture as well. Inca textile work, metallurgy, and agricultural engineering all show sophisticated techniques that appear without clear developmental stages. It is as if the Inca inherited a package of advanced methods rather than developing them incrementally. The Inca's own origin stories support this interpretation. They spoke of earlier cultures, of knowledge passed down from ancestors or taught by legendary figures. They did not claim to have invented their most impressive techniques. They claimed to be custodians of older wisdom. The Spanish chroniclers who documented Inca culture in the decades after conquest recorded stories from Inca nobles about the origins of Cusco's greatest structures. These accounts consistently describe the finest stonework as pre-Inca, attributed to earlier peoples or to divine or semi-divine beings. While we must interpret these stories carefully, recognizing they were filtered through both Inca political narratives and Spanish cultural biases, their consistency is noteworthy. The people who supposedly built these walls, or whose ancestors built them, attributed them to someone else. Modern archaeologists generally dismiss these accounts as mythology, arguing the evidence clearly shows Inca construction during the period of imperial expansion in the 14th and 15th centuries. And certainly the Inca were active builders during this period. But what if both things are true? What if the Inca were building during their imperial period, but were incorporating, rebuilding, or working around much older foundations? The different qualities of stonework visible in Cusco's walls could then represent different construction periods by different peoples, with the finest work belonging to an earlier era that the Inca expanded upon using their own, somewhat less sophisticated techniques. This interpretation finds some support in recent archaeological dating efforts. While the visible Inca city certainly dates to the 14th and 15th centuries, some researchers have found evidence suggesting occupation and construction at the Cusco site extending back much further, possibly to 2000 BCE or earlier. If the site has been continuously important for millennia, it is plausible that the foundation walls, particularly those buried beneath later construction, could be significantly older than the Inca Empire. But dating stone structures is notoriously difficult. You are usually dating the last time they were modified or the organic materials found near them, not the stones themselves. The mathematics implicit in these walls deserves closer examination. Each irregularly shaped stone in a precision-fitted Inca wall represents a solved geometric problem. The stone must fit its space exactly while providing proper support and maintaining structural integrity. To achieve this without modern measuring tools requires either extensive trial and error, which would be prohibitively time-consuming with multi-ton blocks, or a sophisticated mental model of three-dimensional geometry that allows the masons to work out the solution before extensive cutting begins. Some researchers have proposed the Inca used clay or wooden models to work out fitting problems before cutting the actual stones. This would certainly help and represent smart engineering practice. But even modeling at small scale requires understanding how to translate those models to full-scale execution on hard stone. The precision achievable in models must transfer to final work, and any errors compound when you scale up. The final fitting still requires extraordinary skill and accuracy in execution. The seams between stones sometimes show a peculiar feature that adds another twist to the mystery. Rather than being perfectly flat interfaces, some joints display a slight S-curve or wave pattern when viewed in cross-section. This is not visible from the wall face, but careful examination of joints exposed by archaeological excavation reveals this subtle feature. The two mating surfaces mirror each other perfectly, creating what engineers call a mechanical lock. These wavy interfaces increase the contact surface area and make it effectively impossible for stones to slide apart horizontally. This is sophisticated engineering, the kind of detail that does not happen by accident but requires intentional design to achieve specific structural performance. When you stand in front of these walls and really try to imagine the process of creating them, your mind hits a wall of its own. Try to visualize taking a 50-ton boulder of andesite one of the hardest stones available, and shaping it into a complex polyhedron with 6 different precisely angled and curved faces that must each mate perfectly with adjacent stones you have not even cut yet. Do this using stone hammers and bronze chisels. Do it thousands of times. Maintain such precision that the joints are invisible and the wall can flex during earthquakes without collapsing. The engineering is remarkable. The craftsmanship is extraordinary, and the unanswered question of how exactly this was accomplished remains hanging in the Andean air like the morning mist that clings to these ancient walls. Modern attempts to recreate this work consistently fall short, not from lack of effort, but from lack of understanding. We can describe what the Inca achieved. We can measure it, photograph it, scan it with lasers, and model it in computers, but we cannot reliably reproduce it using the tools and methods we believe they possess. This gap between observation and explanation should be humbling. It suggests our reconstruction of Inca technology and methodology is incomplete. Something is missing from the story we tell ourselves about how these walls came to exist. Perhaps the missing element is time. Perhaps the techniques developed over centuries we have not properly accounted for, with knowledge accumulation far deeper than we have recognized. Perhaps the missing element is a different approach to stoneworking entirely, some method that leaves no archaeological trace, but was fundamental to achieving the precision we observe. Perhaps the missing element is simply a level of skill and dedication we struggle to imagine. Craftsmen who spent lifetimes perfecting their art to a degree that modern brief attempts cannot replicate. Or perhaps the missing element is that our timeline is wrong, and these walls are older than we think, built by people whose names have vanished, but whose work remains. What we know for certain is what is in front of us. Stones weighing tons, fitted together with precision measured in fractions of millimeters, forming walls that have survived centuries of earthquakes, weather, and human interference. We know the Inca did not have steel tools, powered machinery, or modern measurement equipment. We know they built an empire that stretched thousands of miles and lasted barely a century before Spanish conquest. We know they were master engineers who built roads, bridges, and agricultural terraces that still function today. And we know that when it comes to their finest stonework, the technique that produced it remains imperfectly understood, a puzzle carved in andesite that continues to defy complete explanation. The walls of Cusco stand as a challenge to easy assumptions about technological progress and human capability. They suggest that ancient peoples were capable of achievements we struggle to fully credit or explain. They remind us that absence of evidence is not evidence of absence when it comes to knowledge and technique. The tools you can find in the archaeological record are not necessarily the only tools that existed, and the methods you can prove are not necessarily the methods that were used. Sometimes the work itself is the best evidence we have, and that work tells us something remarkable happened here, something that pushed the boundaries of what pre-industrial humans accomplished. So when you visit Cusco, do more than take photos of the famous 12-angled stone. Run your hands along those invisible seams. Try to imagine the knowledge system required to produce them. Think about the centuries of accumulated skill, the trial and error, the success and failure that led to walls this precise. Consider what it means that we, with all our technology and knowledge, find this work difficult to explain and harder still to replicate. These walls are asking us a question, one carved in stone and measured in impossibilities. The question is not just how were these built, but what else do we not understand about the people who came before us? The walls do not answer. They just stand there, fitted together with a precision that should not exist, waiting for us to figure it out.